Hello again. Today I will present a different theory of gravity competitive with Einstein's General Theory of Relativity. Due to the fact that many people watch the beginning of the video and decide on this basis whether they will watch further, I will present the assumptions of this theory at the beginning. 1. Space has the characteristics of substance. It offers no resistance to bodies having mass if they move in a straight line with respect to it with constant speed, and it opposes bodies that move with acceleration relative to it. 2. Light, relative to space, moves at a constant speed c. It is not influenced by acceleration of space, only by its speed. 3. The gravitational field is the accelerated movement of space. The acceleration of space is equal to the acceleration due to gravity at a given point, and the velocity of space is equal to the escape velocity. 4. Space is continuous, and some parts of space can move relative to other parts of space, which means that space can be deformed. This deformation in general relativity is called the curvature of space, which introduces serious confusion because it raises the question of what it is curved in relation to. 5. Bodies with mass are a kind of sinks of space. They consume space. The faster a body absorbs space, the greater its mass. If there are no other forces in gravitational field, bodies with mass have acceleration of space. 6. The principle of equivalence formulated by Einstein, stating that it is impossible to locally distinguish a gravitational field from moving with acceleration in space without a gravitational field, is obvious in this theory because in both cases we have motion with acceleration relative to space. For Einstein, this was merely an experimental fact. The problem of General Theory of Relativity is that it is practically not understood by almost anyone, and the mathematical notation is extremely complicated. It is a tensor notation, and only some of the simplest solutions of the equations of the General Theory of Relativity can be obtained in a strict way, and the rest we obtain in the form of numerical solutions. Several predictions of the General Theory of Relativity I will derive according to this new theory, which is not new. It has already been presented in more or less similar versions for many years. It's not surprising because the features of the gravitational field actually impose this new way of thinking. New for most people who will watch this lesson, but not new for physicists. I have been dealing with this for several dozen years, and I have derived many things, but I stopped in several places. That's why I didn't publish it. But recently I found the research work of Henry Lindner, which allowed me to solve these problems. I'll put a link though to this article in the description of this lesson so that everyone could read it for themselves. It's time to present this theory. What is this different theory of gravity? The title of this video suggests that gravity is the accelerated movement of space. There is a huge difference between the general theory of relativity and theory which perceives space as a material object, that it is a certain substance. It was precisely this assumption that Einstein tried to eliminate from his theory, I mean the concept of absolute motion and absolute rest. In his theory, everything had to be relative, while the assumption that space is a certain substance actually imposes the opposite thinking, that we can talk about absolute motion, absolute rest, absolute acceleration or lack of acceleration, but even his general theory of relativity is actually based on absolute acceleration. Predictions of general theory of relativity on the scale of the solar system are quite close to experience. That is, they allowed to explain the strange behavior of Mercury's orbit. They also allowed to explain the deflection of light in the gravitational field of the Sun. However, when it comes to a larger scale of galaxies and galaxy clusters, the general theory of relativity suffered a huge failure. It turned out that in spiral galaxies, velocity of stars that are farther from the center of the galaxy from a certain distance practically is almost inconstant, which is completely inconsistent with general theory of relativity. On the scale of galaxy clusters, where the objects moving around the center of the galaxy cluster are individual galaxies, it turned out that these galaxies move in these orbits too fast than it would be enough to keep them moving in such an orbit by the force of gravity, the source of which is the matter we know. In the normal world, such a fact would immediately cause the questioning of this theory. However, the opposite happened. Instead of trying to modify this theory, the concept of dark matter was invented. The kind of matter which we can't see because it does not interact electromagnetically or strongly with matter we know. It does not emit light, does not absorb electromagnetic radiation, and it only interacts with matter known to us through gravity. So much of this matter has been added, and it was arranged in such a way that the movement of these stars and galaxies could be explained based on the general theory of relativity. The only purpose of inventing dark matter was to save the general theory of relativity. Not a single dark matter particle has been found. Today I will present another theory in which the phenomenon of gravity is described by the accelerated movement of space, which attributes are material in some sense. We must notice and remember what features space has. For now, we are talking about space without a gravitational field. So we notice that space offers no resistance to uniform rectilinear motion. Then we notice that it opposes any attempt at acceleration. Well, this is a shortcut. Of course, it's not about the acceleration itself, it's about the fact that space opposes any change in velocity vector. This is both acceleration and deceleration, or changing the direction of motion. The speed of light in the inertial frame does not depend on the motion of the source of this light. It should be noted that this feature already suggests some similarity with waves. Movement of the source does not affect the speed of the wave, because the speed of the wave is a feature of the medium. Another property of the speed of light is that the speed of light in all inertial frames is the same. It is confirmed experimentally. It has been proven that in inertial frame of reference, there should be the highest speed of information transfer, and it should be the same in all inertial frames of reference. Such assumption is necessary for the laws of physics to have the same mathematical form in every inertial frame of reference. It turned out that the speed of light was the greatest speed with which information could propagate in an inertial frame. Maintaining this feature leads to Lorentz transformation, on the basis of which Einstein formulated the special theory of relativity, which showed that the measurement of time and length depends on speed. When formulating special theory of relativity, Einstein assumed that the speed of light in all directions is the same. This is not an experimental fact, because it is impossible to measure the speed of light in one direction, because two synchronized clocks are needed, and to synchronize them it is necessary to know the speed of light in one direction. We should remember about it because it is not true in this new theory of gravity. If space has the properties of substance, we can talk about speed of light relative to this space. Then the speed of light in a different direction, this is in one direction and in the opposite direction, would be different in inertial frames moving relative to space. And now let's move on to expressing quite simple formulas and comparing them with the formulas describing slowing down of clocks in the gravitational field, and a formula representing the relationship between frequency of electromagnetic wave received by the observer who is far away from the gravitational field and the frequency of a wave emitted from a gravitational field. So let's first move on to this rather simple problem of the second cosmic speed. This is the smallest speed that must be given to a body at a given height above the surface of the planet or star in order for it to escape to infinity. So we have a planet with mass m, it's the planet or star with mass m. Our body is located at some distance r from the center. It's our body, it's the distance r. Now the question is, what is the smallest speed v, here is v, that must be given to this body so that the body would never come back? Because it has to be the smallest velocity, so the final velocity must be equal to 0. Its final velocity at infinity, and the distance at which this speed will be equal to 0 must be equal to infinity. Let's assume that initial velocity is equal to v and final distance from the center is infinity. Rf is a final distance. It's written here. We can apply Newton's laws of dynamics. The gravitational field is a conservative field. Mechanical energy does not change if there are no external forces. The sum of kinetic and potential energy does not change. Comparing initial mechanical energy and final mechanical energy, we can calculate the velocity the body should have to escape to infinity. It's done here. So it is initial kinetic energy, it is initial potential energy, it is final kinetic energy, it is final potential energy. We know that v, it is initial velocity, it is escape velocity here. Vf is final velocity, r is initial distance, Rf final distance. Final distance is equal to infinity, final velocity is equal to 0. So if we put here 0, this vector will be equal to 0. If we put here infinity, this vector will be equal also to 0. So the right side of this equation is equal to 0. And from this equation we calculate velocity. It is second cosmic speed, also escape velocity. Now we can calculate Schwarzschild radius. It is enough to put c instead of v in this equation. Here we put c instead of v, where c is the speed of light in the vacuum. And instead of r we put here capital R. This is capital R, it is Schwarzschild radius. It's done here. And we calculate from this equation Schwarzschild radius. It is equal to 2 times g times m divided by c squared. What does it mean? For a given mass m, radius r can be determined such that when this mass is compressed into a ball of this radius, we will get a black hole. In this new theory of gravity, escape velocity is velocity of space, and gravitational acceleration is acceleration of space. So if velocity of space is greater than c, we have a black hole. Obtaining the same formula from General Theory of Relativity requires complex calculations. We see that this formula results in a trivial way from the assumption that the velocity of space is equal to the escape velocity. I have written down two formulas here, which are derived from the theory of general relativity. The first formula, it is a relationship between delta t prime, the time measured on the clock located in the gravitational field at the distance r from the center of mass m, and delta t time measured on the clock which is at infinity. And the second formula here, it's a relationship between f prime, frequency of electromagnetic wave sent by the source that is located in the gravitational field, and f, the frequency of electromagnetic wave received by observer at infinity. We see that in both formulas, here, and here, we have factor 2 times g times m divided by r. I can remind you that 2 times g times m divided by r, it is square of escape velocity. So, in both equations, here and here, instead of 2 times g times m divided by r, we can put v squared. And if we put 2 times g times m instead of 2 times g times m divided by r v squared, these two equations, we can write these two equations in such form. The first equation here, and the second equation is here. If we are not inside horizon of the black hole, it means that r, distance r, is greater than Schwarzschild radius, then delta t prime is smaller than the delta t. It means that the clock in the gravitational field runs slower than the clock at infinity. And f is smaller than f prime. It means that observer at infinity will receive a wave with lower frequency than the one sent by the source that was in the gravitational field. Let's see once more. If r is greater than r, capital R, this is then Schwarzschild Radius, then escape velocity is smaller than the speed of light in the vacuum. Then this factor is smaller than 1. This difference is smaller than 1. And this square root is also smaller than 1, and delta t prime is smaller than delta t. And it's the same here. Then this square root is smaller than 1, and f is smaller than f prime. The second formula, this, sometimes is presented in another form. I can show it here in such form, where delta f divided by f prime is relative frequency change. It can be derived from this equation. It's done here. Other feature of the gravitational field actually also imposes such thinking about the phenomenon of gravity as the movement of space. The fact that regardless of mass or shape, at the same height the bodies in gravitational field will begin to move identically if there are no other forces acting. We observe a similar phenomenon that very different bodies with different masses and shapes behave identically. Let's assume that we have several larger and smaller boats on the river. They all move in the same way because their movement depends on the movement of the water. It suggests the idea of gravity as the movement of some substance in which all these bodies are located, and therefore they behave in the same way because this substance affects their behavior in the same way. It suggests that the phenomenon of gravity is related to the movement of space, and if this was indeed the case, it would be necessary to give space the characteristics of a substance. This is contrary to the essence of general and special theory of relativity. Now we can formulate this new theory. We suspect that light moves with constant speed c in relation to space. We noticed that in the case of bodies with mass, if they move with respect to space with constant speed in a straight line, then space offers no resistance. However, if they try to change any feature of the velocity, speed or direction, space provides a resistance. These are our principles. So, the first thing is that space is a substance. This is a huge difference between what Einstein proposes in the General Theory of Relativity, because there he tried to do everything to remove all material features from space. He failed to do so because in his General Theory of Relativity there is the concept of absolute acceleration. So, there is a question in relation to what bodies have acceleration. Assuming that space is a substance and that it can move related to other parts of space, not the ether that moves in it, the concept of the phenomenon of gravity as accelerated movement of space can be formulated. According to the principle of equivalence, it is impossible to distinguish locally being in a racket that is in a space without a gravitational field and accelerating with the same gravitational acceleration as on the surface of the Earth, and being on a surface of the Earth in the same racket that rests on the Earth's surface. The equality of gravitational and inertial mass for Einstein was only an experimental fact, but assuming that the gravitational field is the accelerated motion of space, it is obvious. For Einstein, it was a miracle that two different physical quantities, inertial mass, telling whether the body is easy or difficult to accelerate, slow down, or change the direction of its motion, and the gravitational mass, which indirectly tells us about the weight of the body, the interaction of this body with the gravitational field, that these two different quantities are equal. According to this new theory, it is easy to explain it, because if we assume that the gravitational field is the accelerated movement of space, and that bodies which have mass react to the acceleration of space, which is equal gravitational acceleration, while light reacts only to the velocity of space, which is equal to escape velocity, it is easy to explain, because in both cases it results from the resistance of space to the movement of this body in an accelerated motion relative to space. Let's go back to this case that we throw a body from some given point, which is at the distance r from the center of some planet or star. We throw it upwards. Escape velocity is the smallest velocity that must be given to this body in order for it to move an infinite distance from this planet. And now let's reverse the situation. If now the body was at infinity and its velocity was 0 there, and if it were to fall freely towards this planet, then if it reached a distance r from the center of this planet or star, it would obtain exactly the same velocity that it should have to escape from gravitational field. How can we explain this speed of a body falling inertly from infinity towards this planet or star? According to the new theory, bodies that have mass have the acceleration of space, unless other forces act. The velocity of a body falling freely from infinity towards a planet or star is equal to the velocity of space at that point, because both space and the body had a velocity 0 at the beginning at infinity, and later had the same acceleration all the time. And now, based on these principles, I will derive some predictions of the General Theory of Relativity. This is the slowing down of clocks in the gravitational field and the change in the frequency of the electromagnetic wave sent from the gravitational field and received by the observer who is at infinity. Also, I will derive the formula for the radius of the photon orbit around the black hole. So, this is the radius of a circle at which light can move around the black hole. This radius is equal to 1.5 of the Schwarzschild Radius, so-called horizon of a black hole. In this theory, bodies with mass react only to the acceleration of space. It means they have the acceleration of space if there is no other force, and light, as a wave phenomenon, reacts to the speed of space. It means it moves relative to space with constant speed c, and relative to other objects it gains additionally a speed of space relative to these objects. Adding velocities follows the laws of special relativity, keeping in mind that there is no limit to the speed of space. Let's move on to the first proof. I would like to derive this formula for the relationship between the time read by an observer at infinity on his own clock, this is delta t, and the time delta t prime read by the same observer on a clock resting in a gravitational field. So let's imagine that the second clock is in a rocket whose engines are turned on, but the thrust force is only such that this rocket is constantly at the same distance r from the center of the planet. We have these two photon clocks. The photon clock that is in this rocket, and photon clock at infinity, and two observers. So when it comes to this clock, which is at infinity, the space is not moving there. So light moves at the speed of light c, and is reflected from these two mirrors. Distance between these mirrors equals to c times delta t, where delta t is time measured by this observer. It is different in the case of this clock that rests in the rocket, which is at the same distance from the center of the Earth. If this observer, who is in this rocket, wants the light to move between these mirrors, he has to send it at some angle to these mirrors, because space is moving in the direction of the center of the Earth with the speed v. This is the speed of space. It's moving in the direction of the center of the Earth. V is equal to escape velocity. Relative to space, this light beam, relative to space, this light beam will travel distance c times delta t, where delta t is time measured by observer at infinity. And space will travel distance v times delta t, where delta t is also time measured by the observer at infinity. According to the special theory of relativity, the length of bodies does not change in the direction perpendicular to the motion, so the distance between the mirrors, these mirrors, will be the same both for an observer at infinity and for an observer in the rocket. While the beam of light in the rocket is moving, it is still at the same distance from the Earth, so at each moment the speed of space on the path of the beam of light is constant and equal to v. Let's assume that at a given moment a third clock falls freely from infinity. This is this third clock. It is falling freely from infinity, and in that moment it is just beside this rocket. We know that the frame of reference associated with this clock is an inertial frame, so in this frame the speed of light is equal to c. For bodies that have mass, the frame associated with a rocket is not inertial because it moves with acceleration relative to space, and bodies that have mass, react to the acceleration of space. However, light only responds to the speed of space, which is constant during the movement of the light beam between these mirrors. For light, the frame associated with the racket is inertial, and light moves in it with a constant speed. It will cover a distance between the mirrors equal to c times delta t prime. Now we can write down the Pythagorean theorem for this triangle. It is done here. And calculate from this equation delta t prime. It's done here. Then instead of v, we can v squared, we can put 2 times g times m divided by r. And we see that we obtained equation that is derived also from the general theory of relativity. And if we assume that radius r is greater than Schwarzschild radius, then speed of space will be smaller than c. So this square root will be smaller than 1, and delta t prime will be smaller than delta t. This means that a clock located in a racket resting in a gravitational field runs slower than a clock located at infinity. From the point of view of an observer in the racket, the light in the clock falling freely from infinity has traveled distance c times delta t prime between the mirrors. And the mirrors in this frame of reference have traveled a distance v times delta t prime. The distance between the mirrors is the same, these mirrors, is the same for the observer in the racket and in the frame of the falling clock, because there is no change in length in the direction perpendicular to the velocity. Therefore, the distance between the mirrors of the falling clock measured by the observer in the racket can be replaced with the distance measured by the observer in the falling frame of reference. It is equal to c times delta t bis, where delta t bis is the time of motion of the light beam measured in the falling frame of reference. Now we can write down the Pythagorean theorem for this triangle and calculate delta t bis from this equation. It's done here. This is a Pythagorean theorem for this triangle, and we can calculate from it delta t bis. We see that if v, the velocity speed of space, is smaller than c, then delta t bis is smaller than delta t prime. From the point of view of observer in the racket, resting in a gravitational field, a clock falling freely from infinity runs slower than his clock. If we insert the right side of this equation into this equation instead of delta t prime, we will obtain a relationship between the time read by an observer at infinity on a free falling clock and the time read by the same observer on his own clock. This is the relationship here. We see that delta t bis is smaller than delta t if v if V is smaller than c. According to an observer at infinity, a free-falling clock runs slower than its own clock. And here you can see the derivation of this last formula from Einstein's theory of relativity using the Schwarzschild metric. Due to the fact that the freely falling clock moves radially towards the black hole, the change in the angle phi and theta is equal to 0, and the Schwarzschild metric takes this form. TB is its time measured on a falling clock, T time measured on a clock at infinity, R, capital R, is Schwarzschild radius, V velocity of space, it is the same formula which I derived from new theory of gravity, as you can see. Now I will derive the formula combining the frequency of an electromagnetic wave sent by a source located in a gravitational field and the frequency of this wave received at infinity. The only thing we need is this equation. It was derived earlier. In this equation, delta t prime is time measured on a clock in a gravitational field, and delta t is time measured on a clock at infinity. Let's assume that instead of light, electron oscillated between the mirrors in the racket resting in the gravitational field. The relationship between the period of its motion read by the observer at infinity on a clock located in the gravitational field and the period read by him on a clock at infinity would be the same as this formula between times. Frequency is 1 divided by the period, so the period is 1 divided by frequency. By making such a substitution in this equation, we'll obtain this equation, and substituting v squared by 2 times g times m divided by r, we'll obtain this equation. The frequency of the electron's motion will be equal to the frequency of the electromagnetic wave that the electron's motion created. We see that the frequency of the wave received by the observer at infinity is lower than the frequency of the wave emitted by the source located in the gravitational field. This is the same relation as is derived from Einstein's General Theory of Relativity. Now I will derive the formula for the radius of the photon orbit around a black hole. It turns out that it does not have to be a black hole. It turns out that light can also move in a circular orbit around a neutron star. This whole derivation is here. So we have at our disposal several formulas from the previous parts of the lesson. We assume that gravity is the accelerated movement of space. In the case when we have just one star or planet or one black hole, the space is moving towards the center of the planet, the center of the black hole, or the center of some star. And let's assume that there is only one planet, or one star, or one black hole. I will try to derive the formula for the photon orbit for this case. We only need a few formulas. The speed of space, it is square root of 2 times g times m divided by r. The speed of space is equal to escape velocity. We need formula for Schwarzschild Radius. This is the radius of the horizon of black hole. It is the radius for which the escape velocity is equal to the speed of light. So all we need to do is to put here the speed of light and calculate radius. It's done here, where r is Schwarzschild radius. We need a formula for centripetal acceleration in uniform circular motion. It's here. It is v1 squared divided by r. v1 is the speed of light moving in a circular orbit as observed by an observer at infinity. v1 because the symbol v denotes the speed of space here. In inertial frames, the speed of light in vacuum is equal to c in relation to the objects it moves next to locally, and here we are talking about this speed v1. This will be the quantity obtained by dividing the distance traveled by light by the time measured on the clock of the observer at infinity. It is not exactly local speed, because the local speed should be measured on the clocks which a beam of light passes. Time of motion of this beam of light had to be measured in this local system on the clocks that are located there if we want to measure a local speed. We want the beam of light to move in a circle, so it should move perpendicular to the direction of movement of space. And we know that in the direction perpendicular to the direction of movement of space, the distance traveled will be the same according to the observer who is in the place where the light is moving, and according to the observer who is at infinity. However, the measured time by an observer who is in the place where this beam is moving in a strong gravitational field, and the time measured by an observer who is at infinity will be different. The time measured by an observer at infinity will be larger, so if we divide the same length by a longer time, we will obtain a speed that is smaller than the speed of light in the vacuum. This observer here locally, of course, measured the speed of light equal to c, so locally it is correct. We must understand what is this speed v1. We need also the acceleration of space. So, on the basis of this theory in main postulates, it was said that the gravitational acceleration in a given place at a given distance r from the planet or star of mass m is the acceleration of space at this point. So it is equal to g times m divided by r squared. It's here. So let's assume that here at the bottom There is a black hole. Let's assume that the rocket is at a constant distance from the black hole, at a distance equal to the radius of the photon orbit. A beam of light was sent from the rocket in such a direction that it continues to move in a circle around the black hole. From the point of view of an observer at infinity, the beam was not sent by the observer in the rocket in a direction perpendicular to the orbital radius, but at a certain angle to this direction, because otherwise space moving towards the black hole would direct the beam of light towards the black hole. We see it here. The light was sent at this angle by observer who is in this rocket, because at the same time space moved in this direction with this speed. The velocity v1 of the beam relative to the observer at infinity will be equal to the vector sum of the speed of light relative to space, this is c, and the velocity of space relative to the observer at infinity. This velocity will be vector sum of c and v. From this triangle we can calculate the velocity v1 squared. It is done here. The centripetal acceleration is equal to acceleration of space, and acceleration of space is equal to gravitational acceleration. And to the formula for a centripetal acceleration, here instead of v1 squared we put c squared minus v squared. It's done here. And then we multiply both sides by r, and instead of v squared we put right side of this equation 2 times g times m divided by r, and from this equation we calculate the radius of the photon orbit. Next we divide radius of the photon orbit by Schwarzschild radius. Is done here, and we have result 3 divided by 2. Connecting left side with right side, we have such equation, and after simple transformation we see that the radius of the photon orbit is equal to 3 divided by 2 times Schwarzschild radius. This result is identical to the formula derived from Einstein's General Theory of Relativity. The slowing down of clocks in a gravitational field and the gravitational field in general can be described equally well by assuming that we have flat space on the largest scale, but with locally moving space. Just as we often explain what a black hole is by depicting it as a kind of a waterfall of space, in which space moves in towards the black hole from a certain distance from it at a speed greater than the speed of light, which prevents even light from escaping from it, because it moves relative to space at the known speed of light in the vacuum. Presenting the phenomenon of gravity as the accelerated motion of space, assuming that light moves with this space and does not change its speed relative to space, and assuming that bodies endowed with mass feel the resistance of space only when they move with acceleration relative to it, it allows us to explain the slowing down of clocks in the gravitational field, the existence of black holes, and the radius of photon orbit. This is the orbit in which light can move around a black hole, based on the spatial theory of relativity, which does not assume the existence of the gravitational field. Gravitational acceleration would then be the acceleration of space relative to points with zero gravitational field intensity far away from bodies endowed with mass. Moreover, in this approach, the principle of equivalence formulated by Einstein, which states that locally it is impossible to distinguish motion with acceleration in a space without a gravitational field from the phenomenon of gravity, is obvious, because both have their cause in motion with acceleration relative to space. This concept explains in a trivial way why, on the largest scale at which we observe the universe, experimental results indicate that at this scale the curvature of space is zero, which, for physicists using the general theory of relativity to describe the phenomenon of gravity, seems to be some miraculous coincidence that cannot be explained. According to the theory explaining gravity through the movement of space, this is obvious because on a larger scale, with the uniform distribution of matter on this scale, local movements of space neutralize each other. Perhaps this could explain the excessive speed of stars in spiral galaxies and the excessive speed of galaxies in galaxy clusters by the movement of space being dragged along by rotating stars and galaxies. They would not only undergo the acceleration of space towards the center of the system, but would also gain additional speed in the direction tangential to the velocity due to the rotating space. Inventing the existence of dark matter might then be completely unnecessary. We must remember that dark matter was invented to save Einstein's general theory of relativity, because without it, the experimental facts would not be consistent with it on a larger scale. The fact that to this day, for several dozen years, no one has found even a single particle of dark matter should lead to the search for alternative solutions. Unfortunately, most universities have been taken over by physicists who have devoted several dozen years of their lives to searching for dark matter, and who would perceive the abandonment of this concept as proof of the senselessness of their actions. Therefore, they do not only invent dark matter, but select its features so that the experimental facts can be explained based on the general theory of relativity, and if subsequent measurements do not meet this condition, they assign new features to the dark matter that restore compliance with the general theory of relativity. String theory is undergoing a similar process, subsequent versions of which turned out to be incorrect and were saved by introducing patches that restored consistency with experience, which most often consisted of adding additional dimensions of space. General relativity on a smaller scale gives results very similar to measurements, but on a larger scales galaxies and groups of galaxies, it differs dramatically from the measurements. It is more likely that it is not fully true, and on a smaller scale it is only an approximation of a more general theory, than that it is always true and requires the assumption of existence of a huge amount of dark matter that no one has ever found. Perhaps dark matter exists, but for today, sticking to this prosthesis of the general theory of relativity can only be explained by a psychiatrist analyzing the minds of thousands of physicists who have devoted their lives to searching for dark matter and do not want to admit their mistake.